So we have the shorter period today, so don't worry, I'm not going to talk faster to make up for stuff. A couple things just to know. If you owe me any homework, then Monday, December 13th, class is the last day to submit it. Got it? So if you go back to the grade book and you're like, oh, I'm missing these two things, get them done. And show me, and I'll make sure I give you full points. And if you owe me any quizzes or tests and not completed yet, then those must be done by Thursday, December 16th, so a week from tomorrow. Got it? Make sense? That's not too hard, especially because there's some students that might owe me a test or quiz from, that's more of my freshman Algebra 1 classes. So, all right, hey there. All right, so I'm on page 207, 4.3. You said 1 through 8 is what I gave you. Does that sound about right? 207? Yeah. Hey, buddy. All right. All right, so problem number 1 says probability both kings. Okay, let's see. So it says you select 2 different cards randomly from a standard deck of cards. Ooh. So you have 52 cards in this deck, and you pull a card, and you pull a card. Okay? Now, it states to me that I'm not replacing. I'm basically shuffling a deck of cards going 1, 2. There's 2 cards out. Agree? What's the probability they're both kings? Well, the first one is a 4 in 52 probability. The second one is a 3 out of 51. Okay, you might not know what the card is. It's just that's what would take place. And that's 12 over whatever 52 times 51 is. Anybody? Anybody? Bueller? How much? 2,600. Okay, 2,652. Is that what I heard? All right, so go 12 divided by 2652 on your calculator. It's a decimal. What's 12 out of 2652? 0.0045. So that means you have a 0.45% chance of drawing a king and a king out of a deck of cards. Cool? Then problem number 2. Ooh, look at this. I made it fancy. Both are red. Okay. So again, this is coming out. 52 cards. We got a red and a red. Okay? So that means that we have half the deck is red. So it's 26 out of 52. And then that means there would be 25 out of 51 left. This reduces to 1 over 2. That was easy. 25 over 51, which is 25 over 102. Help me out. What's 25 divided by 102? 0.245. So you have a 24.5% chance that if I shuffled up a deck of cards really well, and then said 1, 2, what's the probability they're both red? 24.5% chance. Okay, and this is, we are not replacing these. We are taking them one at a time. So just know that sometimes you will replace something that you won't. Problem number 3 says probability, the first card is an ace, and the second card is a king. Well, it doesn't really matter. This is kind of lingo that they kind of get goofy with. How many aces are in a deck of cards? So I have 4 out of 52. How many kings are in a deck of cards? How many cards are left after I pulled one of the cards out? Do you see how I did that? Does that make sense? What is 52 times 51 again? What is 16 divided by 2652? 0.006. Is that right? So that means I have a 0.6% chance of drawing an ace and a king when I pull 2 cards out of the deck. And again, these did not say that we did replacement. It just means 2 cards are handed to you. What's the chance you have an ace and a king? Okay. Problem 4. Probability you'll end up with an ace and a king regardless of order. This is the same. You know, I'm not going to make you go through it, but it's the exact same probability. It's the same as this. All right, problem number 6, or excuse me, 5. You have 6 red and 4 green, and you select 3 marbles. So what's the probability that you have 3 green? Okay, and again, this means I have these marbles. I go 1, 2, 3. Take 3 marbles in my hand. Boom, you have your hand. Are they all green? Well, there's 4 out of 6 green, and then 3 out of 5 green, and then 2 out of 4. And if I get fancy with this math, I can say, oh, this 4 reduces this 4. This 2 goes here. That's 3. This 3 reduces here. Yay. We have a 1 in 5 probability, so we have a 20% or 0.2% chance, which is a 20% chance that you select all green just by reducing fractions. You.
Why would it not be out of 10? Is it back red and green marbles?
Oh, because I got excited about what I was doing. 4 out of 10, 3 out of 9, 2 out of 8. Sorry, this was incorrect. Stirrup got all excited about something and made a mistake.
Okay, we all get excited about marbles sometimes.
I know. That and fire trucks.
Yeah, they're exciting.
All right, so I have a 1 in 30 chance of doing that. What's 1 divided by 30? Point. How much? 0.03 continuing. So that means and 3. So we have a 3.3% chance of pulling all 3 green out without replacement. All red. So number 6, all red. Yeah, question?
Yeah. So like, how exactly could you get like for number 5, like can you tell me how you got these numbers? Like how
Okay, so there's
the fract, like the bottom of the fract, like the denominator.
okay. So we have 10 marbles total, so that'll be the denominator. But as I drop 1 marble out, that means the denominator reduces by 1 because I'm not putting it back in.
Like 0%.
Yeah. So think of it this way. Let's say you're reaching in something and they said, hey, grab 1, 2, 3 in your hand, so you have no idea what they are, and then you pull them out,
Yeah, that's
and then you
not
look.
what we're doing.
No, that's exactly what we're doing. So all 3 could be coming out at the exact same time. I'm not doing this going, I get this, put it back in, get this, put it back in. So I'm not replacing.
Oh, so like the probability of getting another one is less because of the pulled one.
Yeah, so like you're assuming you pulled 1, so 1 of the 4. Now there's 3 left. Grab another one. Now there's 2 left. You're assuming you got it. So you have a 3.3% chance that did happen.
Okay.
Okay. So probability of pulling 4 red, 3 red.
4 red.
4 red?
No,
3. 3 red. Sorry. So there are 6 red marbles out of 10, 5 marbles out of 9, 4 marbles out of 8. And I like to reduce these. Some people don't like fractions as much as Stirrup does, but you know, everyone's got to be a little weird in some sense. So 2 times 1 times 1 is 2. 2 times 3 is 6. 6 times, oh, I could reduce that. Yeah. So that's a 1. 1 out of 6. We have 1 and 6. 1 and 6 is 0.666. So we have a 6.6% chance of drawing all 3 red marbles. There was 10 originally.
I got 1. Yeah, I got 0.16.
0.16? Okay. So 0.16, so 16.6%. Again, Stirrup got a little out of control. Number 7, red, green, red. Okay, this doesn't really matter because we're not replacing. Okay, So red, there are 6 out of 10. Green, there would be 4 out of 9. That reduced because I already drew one in my hand, right? And then I go back to red, so there's 5 out of 8. Now, the reason this doesn't matter, like the red, green, red doesn't matter. I could have made that red, red, green. I could have made it green, red, red. It doesn't matter what combination. Because notice we're multiplying, and when you multiply, it doesn't matter what order you're doing it. Okay? So all things will start to reduce, and that's why I'm reducing it. Of course, I can't do math to save my life. So that's 2, that's 3, that's 1, that's 2, that's 2, that's 1. So we have a 1 in 6 probability of that taking place, which is 16%.
Yes.
0.16, which is 16%, roughly. And then 8. All are red or all are green. Ooh, skip number 8. Because I know it's not on the final. All right, so that is that. The last thing I wanted to teach y'all about, and then we'll spend the next 2 days after that kind of going over things. All right, these are called contingency tables. So they have so we're going to do this. These don't have to be even. I'm just trying to itemize things so it's easier to see. This is going to mess with people because, like, dude, you made it messy. Sorry. All right, we have the Atlantic, Pacific, Indian, and total. We have category 1, 2, 3, 4, 5, and then the total. Okay, category 1, you had 20, 16, 10, 5, 2, and there's 53 total there. 16, 8, 6, 5, 4, 39. 10, 4, 2, 1, 1, 18. 46, 38, 18, 11, 7, and 110. Okay, so let's talk about how this table works. Pretty straightforward. Attendance right now. Okay, so what they've done on this table, in the Atlantic Ocean, there was 20 Category 1 hurricanes. There was 16 Category 2. There was 10 Category 3s, 4 Category 4s, 2 Category 5s. So a total of 53 hurricanes in the Atlantic. Same with the Pacific, Indian. So that's how they're getting the final total. As far as Category 1, there was 46 Category 1s in the 3 oceans. There was 38 Category 2s, 18 Category 3s, 11 Category 4s, and 7 Category 5s. Okay? So that's just talking about the type of storms. Okay, so contingency tables work in 2 ways. It's a way of kind of going through and tabulating. So by looking at this, what is the probability of selecting a Category 1 hurricane? So how many hurricanes were Category 1 in our table? 46. How many total hurricanes happened? Yeah, 110. That's the big total. Okay, so that's what it comes out to. You can reduce it if you want, or you can make it a decimal if you want. It doesn't really matter. What's the probability you select a level 3 or higher? Okay, again, there's 110 total. So category 3 is 18 plus 11. That's 29. 29 plus 7 29 plus 7 is 36. So I have a 36 out of 110. Okay, so it's just a matter of going through the category and seeing it. Selecting Atlantic or Pacific hurricane. Well, again, there's 110 hurricanes that we're dealing with. Atlantic had 53 and 39, so whatever 53 and 39 add together. That's what, 92 out of 110? Okay, selecting an Atlantic Category 1 hurricane. Okay, so this is where it starts changing. So we want probability of selecting Atlantic Category 1. Okay, again, so we have 110 hurricanes. Atlantic Category 1 is how many? 20. Okay. Probability of selecting a hurricane that is Pacific and less than 3. Okay, how many happened in the Pacific total? 39. Less than category, says less than category 3, so category 2 and 1. So it's what, 24? 24 out of 39. And then probability of selecting Cat 1 or Pacific. Okay, so you have to be careful with this. Now we still have 110 total. Category 1 was 46. Okay, so that's category 1. For Pacific is 39. Okay, now you have to be careful with this. So I have plus 39. Is there a region between here to here that I can come back to that would be a shared region? Yeah, you don't want to double count that 16. That 16 is a part of the 46. That 16 is also part of the 39. So I have to take one of them away. One of the 16 away. So if I take one of the 16 away, that means I'm dealing like with this category and this like this kind of thing. Okay, or this kind of thing, excuse me. So I have to include it once. So if I add those together, it looks like 69 out of 110. Okay, so the denominator on each of these is 110. That happens because we're talking about all of the storms all together, what we would do with it. Pacific, oh, this one should have been 110. So Pacific, that should have been 110, I'm sorry, because it wasn't conditional. So conditional probability gets a little different. Okay, so we're still going to use the same thing, but this goes into the conditional. So probability that it's a Pacific hurricane and category 5. Okay, so what you're doing on this is you're saying, hey, we want the Pacific, happens to be 39 of them. How many of them have any category 5? 4, so I have a 4 in 39 chance of that happening. Because it's conditional. It's saying, hey, I know I'm picking a Pacific. Hey, I know I want to know what this, how many storms were in the Pacific? 39. How many were category 5? There was 4. And then, yeah.
So one of the problems on the homework, it's asking about eye color that's for the same category. So how would you do an or that's in the same category?
We'll hit it tomorrow.
So, okay.
Okay, another way I could have represented this is Pacific such that category 5. This means the same thing, just a different way of writing it. Okay, so let's see. What should we give you? Because we're almost out of here, right? What time are we out here?
9.
Oh, wow. Really?
I think 2.
Oh, faster than I should have. All right, so with that continue. Are you talking about number 3?
Yes.
Person has green or hazel eyes. So you're going to combine the green and hazel. Green and hazel eyes is 16 people. So you're going to use both of them.
do 9 plus 7 equals 16?
Yes. And you don't have to worry about necessarily reducing them. So what do we say we do? Page 209, 1 through 10. If you're here today, I'm giving you the points for yesterday's homework. Same with tomorrow, rather than walk around the room. But again, friends, if you owe me any homework, if you look in your grade book, by Monday, December 13th, that's due. If you owe me a test or quiz, then it has to be done by December 16th. That's Thursday next week. Okay, if it's not, if you started it, I'll grade what you have. If you haven't started it, it's really easy to grade what you haven't done because that's 0 still. All right. Stop.